Hello learners, I am Dr. Munish Kumar Bhardwaj from School of Engineering and Technology of England. And today we will discuss about the sources and type of defects in stone and brick masonry. As you remember, till now we have discussed defects in buildings, in which we discussed introduction to defects, defects in timber, defects in steel, defects in sanitary fittings and plumbing. Then later on we started discussing about the repairing materials. These materials for defects in timber, for defects in steel, for defects in sanitary fittings and plumbing. Then for miscellaneous defects, lastly we discussed about the repairing of floors. Now we are moving to repairing and preventive maintenance techniques for strengthening of stone and brick masonry. The content for today's discussion is sources of defects and diagnosis and measurement of defects. These two topics we will be discussing today. The objectives of this module are that after the end of this module, you should be able to describe the sources of defects in brick masonry and stone masonry, and also you should be able to explain the process of diagnosis and measurement of defects. First of all, let's begin with what is the purpose of repair. Strengthening of stone and brick masonry structures enhances the life and functions of the structure. So this is the first reason why we go for repair. Timely action of strengthening will extend structure's life and conserve resources which have to be used otherwise to rebuild the damaged structure. Because if the building is damaged, then we have to rebuild it and lot of resources will be used for that. So it is better that we do the timely strengthening of the structures so that it can be used for a longer time. And what is the need for strengthening? The stone and brick masonry structures require strengthening in two situations. First, due to weakening over a period of time, starting with normal wear and tear on their surfaces due to exposure to natural forces such as weathering action, deterioration of materials, functional use, etc. These are some of the facts which do the normal wear and tear to the structure. Secondly, due to unanticipated hazards such as fire, earthquake, cyclone, etc. Now let's see what are the sources of defects. Building defect may be defined as an imperfection, deficiency, or fault in a building element or component which adversely affect its functional performance and appearance. In case of stone and brick masonry, some defects are the natural consequence of aging and normal use, but many premature failures can be traced due to lack of proper skill and care during construction and maintenance. Masonry undergoes decay due to aging, weathering, and subsequent damage. It is quite likely that structures are not maintained properly, and once the decay starts, accelerated damage takes place. In comparison to stone walls, brick walls are more prone to deterioration, particularly when it is not covered with any protective coating such as plaster, slurry coating, or cement-based painting. Climate conditions such as prolonged and severe rain and saline and chemical environments hasten the deterioration of brickwork. Poor quality of cement used can be the main reason for deterioration, and it is hastened due to saline and chemical environments. Some of the commonly experienced defects calling for strengthening in brickwork and stone superstructure are: first, use of bad quality bricks and stones, rainwater splashing on unprotected surface, decay of wall due to leakage from rainwater pipes and gutters, reaction of brick or stone with salinity in the atmosphere, sulfate attack on mortar, and crystallization effects. Next is brick and stone withering out. Now let us see these one by one. Use of bad quality bricks or stones. Bricks or stones used for masonry work must conform to the quality standards laid down by the Bureau of Indian Standard. Quality standard must be ensured at all stages of masonry work, because if we are using the substandard or poor quality material, then certainly it is going to be affected by environmental factors and other factors, and there will be problems in the structure. Rainwater splashing on unprotected surface. What happens because of this? Due to rainwater splashing, underburnt bricks and bricks made out of poor clay get badly affected. If only a few bricks are affected, it would be enough to cut and replace the affected portion with good quality bricks. Where the problem is more severe, affecting the entire wall, the remedy lies in either providing an impervious layer of cement plaster after thoroughly cleaning the surface, or in the extreme case, you can go for replacing the entire affected brick wall. Next is decay of wall due to leakage from rainwater pipes and gutters. Defects in gutters may lead to water continuously flowing over the affected portion of the wall, causing decay of the wall. Check the point of leakage, and corrective measures should be taken to prevent gutter water flowing over the wall. Don't allow the gutter water to flow over the wall. Next is reaction of bricks or stone with salinity in the atmosphere. This is quite common in coastal areas. Salinity in the atmosphere reacts with the bare bricks in the wall, leading to withering and disintegration. What is the remedy? Remedy is in providing a cement plaster coating in the brick walls and periodical painting with cement based paints to fill up the hair cracks that may develop in cement plaster, so that the salinity does not penetrate to the brick face. Next is sulfate attack on mortar and crystallization effects. Bricks are affected by sulfate in mortar due to expansion of mortar, leading to cracks. This results in brick edges spalling off. The remedy lies in reconstruction of the affected portion. Next is brick and stone withering out. Various natural factors coupled with negligence keep on attacking the stone and the brick masonry, thereby causing further damage in stone and the brick masonry. Levels in source of defect, or you can say the stages at which the defects may creep in the structure. So these levels or the stages are conceptual level, then design level, then construction level, then user level, and the last one is maintenance. So at these different stages, if we are making some mistake, then certainly the building will be witnessing some defects. So we have to be very careful at all the stages of design and construction. That is the meaning here. So at conceptual level, it is often said that defects start on the drawing board, means at the planning stage. This may stem from unrealistic cost limits. First of all, if you are putting some cost limits, then certainly there will be compromises. Compromises in the material, compromises in the workmanship. Failure to give real vital information on the functional requirements of building for choosing the proper masonry elements in the building. Means if the proper information regarding the functional requirement of the building is not given at the planning stage, then certainly there will be mistakes, and these mistakes will lead to the damage to the building. Then at design level, the most common faults for stone and brick masonry may be grouped as under. First is failure to follow established design criteria in the choice of masonry system and selection of materials. So this will lead to the problem in the building. The next is ignorance of the properties of materials, especially when more than one material is used. This is very important. First of all, we should be well aware of the properties of the materials, and when you are using different materials in combination, then it becomes very important, because if there is a huge change or large change in the characteristics or the properties of the two materials that are being used together, then there will be a problem, because due to temperature changes there will be a different behavior of the material due to different thermal coefficient of expansion or contraction. So next is use of new materials without performance data and time tested qualities. Because if some material is in the market and if proper data is not there available regarding its performance, then it may cause problem with time. So one has to be very cautious while using the new materials. Then misjudgment of climatic conditions under which the materials have to perform. That the material will perform differently in different climatic conditions. So we must have proper information regarding the behavior of the material in different climatic conditions, and then only we should choose the material according to that performance of the material in that particular climatic condition. Then poor communication from design to construction team. Means design team has decided something, but it is not properly communicated up to the construction team, which is finally going to construct the structure in the field. Then certainly due to this miscommunication there will be problems. Then construction level or construction stage. The most common causes leading to defects in stone and brick masonry are a realistic working environment not considered in designs, coupled with emphasis on speedy completion, leading to careless and skimped masonry work. Also, absence of quality assurance groups to ensure greater care in quality of materials and techniques used in masonry construction at all stages in the construction process and closer supervision. Next is user level or the user stage, at the stage when the building is open for the use. Defects may be caused by unintentional misuse through a lack of information on the correct mode of use, or by deliberate act of vandalism. Such acts may cause defects which will have serious economic implications, because if some damage is there because of use, then ultimately finally you have to replace that, so you will be spending money on that. So that economic implications are there. Sometimes the design loads are exceeded by the users, resulting in cracks in the building elements. This is also there. Then finally the maintenance level. Incorrect identification of the true cause of a defect followed by inappropriate remedial work in stone and brick masonry will not only fail to rectify the original defect but also may substantially worsen the condition of the building. This is important as masonries quite often serve as load-bearing structural support for the whole building. Deterioration and improper alterations during the service life of the building affect actual margin of safety provided for the building. Hence, it is important to evaluate the potential hazard of each building proposed for rehabilitation. Following such an evaluation, the cost of appropriate strengthening or retrofit procedures has to be calculated so that the feasibility of various schemes to mitigate unacceptable hazards can be determined. Now we move to diagnosis and measurement of defects. Cracks are indicators of defects. Cracks in different structural members in a building are good indicators of the sources of defects. Types of cracks. If we consider the orientation of crack, then we can divide the cracks into three categories: diagonal cracks, horizontal cracks, vertical cracks. Diagonal cracks at lintel and sill level are caused due to differential strain between the lightly loaded masonry below the opening and heavily loaded adjoining masonry where no opening exists. Here you see the diagonal cracks in the wall. Horizontal cracks in the topmost story below the slab level occur due to horizontal movement of the roof slab resulting from shrinkage and consequent pulling of slab, causing lifting up at its edges as shown here in the figure. So you see here the horizontal cracks. Then vertical cracks. Vertical cracks can be caused due to differential settlement of foundation. As you can see, a vertical crack in the wall, which may be caused due to the differential settlement of foundation. Cracks can be caused at junction of two dissimilar materials used in the wall. For example, concrete and brickwork, due to difference in thermal coefficient of expansion of materials. All these cracks can be repaired after enlarging the cracks and filling the crack by appropriate mortar or using patent compounds or mastings. Generally, this method is applied in case of dormant cracks, fine pattern cracks, and isolated defects. Disadvantage of this method of repair is that the repaired portion gives unpleasant appearance with protruded surface. Now, cracks can also be classified based on the nature of the cracks. So what are these cracks? First is tensile crack. Tensile cracks are developed in masonry wall due to tensile forces, as you can see in the figure. So here in the almost middle of that wall, you see a crack which is due to the direct tension. So it is a tensile crack. Flexural tension cracks at lintel level due to shrinkage and construction of slab is shown here. You see here the crack near the opening, top portion of the opening here. Shear crack. Shear cracks occur at corners of wall. Here you see that at the corner of wall B, due to the expansion of wall A, the shear crack is there. So at the joint of these two walls A and B, you see a shear crack here. Shear crack in masonry pillar occurred due to expansion of RCC beam. These cracks are shown here in this figure, that due to the expansion of the RCC beam, there is a shear crack in the pillar. Cracking due to expansion. Cracking due to expansion of brickwork is shown here in this figure. That due to the expansion in the different portions, there may be the cracks in the wall. Then cracks by the side of door frame with wall surface on both sides is shown here in this figure. Then cracking in topmost story of a load bearing structure due to compaction and concreting in slab and the beam. That when you are doing the compaction and concreting in the slab and the beam, there may be some cracks in the topmost story of the load bearing structure. As you see here, the cracks in the wall, shear crack in the pillar, it is seen when the concreting and compaction was done in slab and beams. Then horizontal crack at the base of brick masonry parapet support on a projecting parapet is shown here. You can see in the parapet, horizontal crack in the bottom portion of the parapet is shown above the wall in the elevation you can see here. Vertical cracks in multi-story buildings having window openings in load-bearing walls. This is very common. Wall marked A on both the side portions of the middle portion. Here you see here A is marked here. So wall marked as A acts as pillars and are stressed much more than the central portion B, resulting differential stresses. The cracks developed in walls are shown here. Vertical crack at the junction of RCC column and brick masonry due to expansion and contraction of RCC and brick masonry is shown here. You can see the crack at the junction of RCC column and the brickwork. Then vertical crack in brick wall panel of framed structure due to expansion of brickwork is shown here in this figure. You see the crack in the brick masonry. Then cracking of a partition wall supported on RCC beam when length to height ratio is large and there is a central door opening, as you can see here in this figure, that in the wall there is a opening, door opening is there and cracks are appearing in the wall. Now let's move to the equipments for diagnosing the defects. The general approach in diagnosing the defects in stone and brick masonry shall be to examine carefully all the symptoms, considering all the probable causes. By a process of elimination, the true cause and its source shall be identified, and then an appropriate remedial action shall be decided. In many instances, a visual examination will be sufficient for an experienced inspector to determine the cause. Where this is not possible, instruments may be used for a more objective diagnosis. There are many portable instruments in the market for investigating the causes of defects which have useful application in brick and stone masonry. These include moisture meter. You can use it to test the comparative moisture content of materials used in masonry work. Then you can use endoscope. Endoscope comprises a slender tube fitted with a magnifier and light source that can be inserted through a small hole to give a view of the interior of the wall cavities and other voids within the masonry work. Magnified graticule. Magnified graticule is used to monitor internal cracks in smooth finishes. The monitoring is conducted by measuring the offset between two pencil marks utilizing magnified graticule. The resolution of this equipment is of 0.1 mm and can be achieved with magnified graticule. Next instrument is plastic telltale. It is used to monitor crack width variation. Means you can ascertain whether there is a change in the crack width or not. Means the crack is dormant or it is active crack. The plastic telltale consists of two overlap plates. The plate with scale marked in millimeter units of measurement is fixed on one side of the crack and the other plate marked with cursor is fixed on opposite side of the crack, and that way you can measure the crack width. The instrument is screwed on the wall in such a way that the cursor of one plate and the middle of the scale of opposite plate are aligned. If crack experiences movement including shear or normal movement, the variation is measured to the closest of millimeters by recording the position of the cursor with respect to the scale. So that way you can measure the variation in the width of the crack. Then glass telltale method. There are two types of cracks, namely dormant and the progressive, as I told you. The glass telltale method is used in order to know the type of crack to ascertain the reasons for the same. In this method, telltale glass pieces of appropriate size will be fixed to the masonry when cracks are noticed, as you can see here. Over a period of time, increase in the width of cracks are observed. If the width of the crack is increasing appreciably, suitable strengthening measures are employed and the defects rectified. Glass telltale neither shows the direction of the movement nor the magnitude of the movement. That is why it is not very popular method now. So in this lecture we discussed about the sources of various kind of defects, then various stages of design and construction which may be the source of defects. Then we also discussed different type of cracks as per their orientation. Then we further discuss about the various type of cracks according to their nature and place of occurrence. And finally, we discuss about the equipments for diagnosing the defects. I hope you must have enjoyed this discussion and go through the text provided and enrich your knowledge. Thank you.